Okay, so now I like this one because now this one is kind of feels very similar to the last one, but we've got a different piece of given information. Okay, now we have a ball that's rolling off at some unknown velocity. We now know where it hits the ground, and we want to know how fast was it rolling. Okay, well, it hits the ground 0.352 meters from the edge of the table. I don't think it matters how high it was. Oh, yeah, I think it does. I think it does. Okay, so look, we know that the distance horizontal, distance in the x direction, is just going to be equal to rate times time. Okay. Well, we know 0.352 is our distance, but we don't know our rate or our time. So in order to find our rate, which is what we're asking for, we're going to need to solve for time. Oh, I understand. This solving for time is going to involve the exact same process as the last problem. So let's solve for time. Well, the y position is equal to the initial position where we begin plus the velocity in the y direction times time plus half of the acceleration times time squared. This is just one of those equations you're going to want to kind of put to knowledge. Now, we know that this thing is going to end up on the ground after some amount of time. We know that it started very reasonably 0.95 meters. There is no velocity in the y direction, or the velocity in the y direction is 0. And that the acceleration in the y direction is due to gravity, and it's listed above. So once again here, we have 4.9 squared. No. 4.9 t squared. Let me squeeze a t in there. Equals 0.95. So t squared is 0.95 divided by 4.9. All right, so let's find our t. T is 0.44 seconds. Okay, all right, good. Now look, we know our distance. We don't know our rate. We do now know our time. So divide each side by 0.44. And you get R is 0.8 meters per second. Hope that helps. Boom.